Okay, class, we're working on 9.2 worksheet. So the first two questions you have here are review questions from first semester. All right, so I'm going to give you a little hint here. So first one says to write the function below in standard form. So when we do that, we want to multiply here. We want to distribute the 3 first. Okay, and then after that, we want to multiply this binomial after you distribute with this binomial. And remember, you can multiply those using the area model like I taught you. In this second question here, we're going to solve it by factoring. So find the x-intercepts. Remember, that's what solve means, by factoring. Remember, you want to look for a greatest common factor first. So if I'm looking at this, there definitely looks like there's a greatest common factor there. Factor that out. All right, and then you need to factor the quadratic and then use the zero product property to solve. Remember, you can factor, once again, using that area model method that I have taught you. Okay, if you need some help with that, let me know. I can also send you some videos. Go back and look at your old notes, but you need to remember and know how to do that. Here is the standard form equation of a circle. This is in your notes, okay, where the center of the circle is h comma k. So your h value and your k value is the center of the circle. And then the radius of the circle is r, your r value. Number one, find the distance between 1, 2 and negative 4, negative 3. So let's plot these points. So 1, 2 is going to be right there. I'm going to label that A. And B is negative 4, negative 3, which is going to be right there. And I'm going to label that B. So we want to find the distance between these 2 points. Now, in order to find the distance, we're going to use the Pythagorean theorem. So how are we going to do that? So what we're going to do is, notice we have this distance here, so I'm going to create a right triangle. So notice how if I line that up there, that I can create another side of the triangle that goes perfectly vertical, and then create another third side of the triangle like that. And notice how now I have created a right triangle. Because of that, we can use the Pythagorean theorem to solve. This side of the triangle, as you can see, is 5 units. This side of the triangle, as you can see, is also 5 units. So we need to find the missing third side because that is the question, the distance between A and B. So we're going to use the Pythagorean theorem in order to do that. We're going to say that A squared plus B squared equals C squared. A and B are always the legs. C is always the hypotenuse. So we're going to say that 5 squared plus 5 squared is equal to C squared. And that means 5 squared is 25 equals C squared. That means that 50 equals C squared. And then to solve for C, we need to undo the square, which is to take the square root of both sides. So when we do that, the square root of C squared is just C. So C equals the square root of 50, which is just a little bit more. If we put that into a calculator here, we can see that the square root of 50, you should be getting that amount. So we can round that up to about 7.1. So we can say approximately 7.1. That is the distance between A and B. And that's how you can use the Pythagorean theorem to solve for the distance between 2 points. Let's look at number 2. It says find the distance between these 2 points using the distance formula. So notice how it's the same exact 2 points. So we should be getting the same answer. We're just going to be doing it differently. So the distance formula, which you know from your notes, is distance equals the square root of, we're going to take the x's and subtract them and square them. We're going to do the same thing with the y values. Subtract them and square them. And then we're just going to combine those distances together. And overall, we're going to take the square root of that. That's your distance formula. So now we're just going to plug all these values in. So let's plug in our x values. You can see our x values are 1 and negative 4. So I'm going to write 1 subtract negative 4 squared plus, we're going to do the same thing with the y values, which are 2 and negative 3. So I'm going to say 2 subtract negative 3 squared. Notice how I stayed in the same order, right? So 1 minus negative 4, 2 minus negative 3. We want to get in the habit of doing that, okay? Even though technically it doesn't matter for this particular exercise, but when we calculate slope and things like that, it does matter. So I'd like you to just kind of get in the habit of just kind of staying in that order, even though technically it doesn't matter for this one. Let's continue to clean this up. So we say d for distance is equal to, we still have our square root. We're going to do that last. So 1 minus negative 4 is 5, right? 5 squared is 25, so that's 25. 2 minus negative 3, that's also 5, squared is 25. So notice how we have 25 plus 25. So that should look pretty familiar from that last problem that we did, right? So that means that that's 50. So the distance is the square root of 50, which is, as we know, about 7.1. So that's using the distance formula. So the distance formula works just fine, or you could use the Pythagorean theorem to solve. Either way, both methods work. Okay, and it's good that you know both methods. Number 3, the midpoint of AB. Okay, so we're using those same exact 2 points. So let's write them down here. So A was 1, 2 from above. B was negative 4, negative 3. Now from your notes, we know that the midpoint is, we're going to take the x values, both of them, add them together, and divide by 2. And we're going to do the same thing with the y values. Add them together, divide by 2. So let's do that. So let's see, our x values are 1 and negative 4. Our y values are 2 and negative 3. Let's go ahead and add those, throw those together, add them together, and divide by 2, and we'll have a midpoint. So the midpoint for this one, we're going to have 1 add negative 3 and divide it by 2. And the second one, we're going to have 2 plus negative 3, and we're going to divide that by 2. So 1 add negative 3 is negative 2 divided by 2. 2 add negative 3 is negative 1 divided by 2. Negative 2 divided by 2 is just negative 1. And then we have negative 1/2 over here. So we can just say negative 0.5, or we can just keep it as a fraction, negative 1/2. This is the midpoint of those 2 points, right? Midpoint means the exact middle between the 2 points. If we go back up to the graph, negative 1, negative 1/2, that makes sense, right? If I go to negative 1, negative 1/2, it's like right, oops, not right there, sorry. Negative 1 and negative 1/2 is going to be about right in there. And I'm a little bit off because my ruler is off, so it's not exactly perfect, but it should be like right in there if I would have graphed it correctly. And that is the middle point between A and B. Okay, moving on to number 4 and number 5. Number 4 says, what's the center and the radius of the circle? So here is my H value, and here is my K value. H and K are the center of the radius. For this one, my H value is 6. My K value is negative 1. Remember, it's just like in quadratics, right? In the parentheses, right? In the equation, it's x minus h, right? So 6 is h. Y minus k. Well, notice how it's not minus k. So I can rewrite y plus 1 as minus negative 1, right? So negative 1 is the k value. Or if you just remember, it's simply just the opposite of what's in the parentheses, right? So our h value, you can see it's minus 6, so it's 6. The k value, you can see it says plus 1, so it's negative 1. So the center of our circle, so we could say the center is 6, negative 1. Now remember the radius, according to the equation, the radius squared makes that number, right? So some number squared is 36. This is pretty small, so maybe you can think of it in your head. It's going to be 6, right? So the way we can always do it is simply just take the square root of that number. We know that the square root of 36 is 6. So that we can say that the radius is equals 6. Moving on here to number 5, you can see that this minus y squared on the other side of the equation has kind of wandered off, right? That's why it says hint right here, move the y squared value first. So we're going to move this y squared value back to the other side of the equal sign where it belongs. So by doing that, I'm simply going to do the opposite. So we're going to add y squared to both sides, and we're going to rewrite our equation. So now we have x plus 7 squared plus y squared equals 12. Now let's name our center. So our center is going to be h and k, right? So our h value, if it says 7, then that means it's negative 7. And our k value over here, right, is 0 because it's just y squared, which is the same as y minus 0 squared. So our h value, negative 7, our k value, 0. So our center of this circle is negative 7, 0. The radius is simply, I'm just going to write r equals, the radius is simply the square root of this value, right? If it's 12, that means some number squared makes 12. Or we just take the square root of 12, which is not a perfect square. Since the square root of 12 is not a perfect square, we can just say that the radius is the square root of 12. If you want to estimate it, I guess you sure can. We can find that the square root of 12 is about 3.5 if we round it correctly. So we can say approximately 3.5. But you don't have to. You can keep your answer in radical form and just say that the radius is the square root of 12. Let's move on to number 6 and number 7. This will be it for this video, and then what I'll do is I'll make another short video going over 8, 9, and 10. So for number 6, it says write the standard equation with the given value. So this time they are giving us the center and the radius, and they're saying, what is the equation? Well, we know from our notes that the equation of a circle is x minus h squared plus y minus k squared equals r squared. So it looks like we're just going to plug in some values, right? H, 0, we'll plug that in for h. K, that's another 0. We'll plug that in there. And finally, the radius, 4. We're going to plug that in there into the equation. And let's just see what we get. So we have x minus 0 squared plus y minus 0 squared equals 4 squared. Now all we have to do is clean this up a little bit and simplify. X minus 0 squared, we can just say x squared. Y minus 0 squared, same thing. We'll just say y squared. You don't have to put the parentheses. I just kind of did it by habit. Equals, and then we know 4 squared is 16. And there's the equation of the circle that has a center at 0, 0, and a radius of 4. Square root of 16, 4. We're going to do the same exact thing here for this last one, right? Let's write the equation of a circle. X minus h squared plus y minus k squared equals r squared. So we have our radius, 5. We're going to plug that in there. We have our h value, which is negative 2. That's going to be plugged in there. We have our k value, which is 1. And we'll plug that in there, and then we'll just clean it up. It's really as simple as that. So x minus negative 2 squared plus y minus 1 squared equals 5 squared. Let's clean this up. X minus negative 2 should be written as x plus 2 squared plus y minus 1 squared is perfectly fine equals, and then we should say that 5 squared is 25. And that, ladies and gentlemen, is the equation of a circle. Has a center at negative 2, positive 1, h and k, negative 2, positive 1, and a radius of 5, right? Notice how the radius is always the square root of this number, right? So if you see 25, that means that the radius is 5, because the square root of 25 is 5. Okay, like I said, ladies and gentlemen, the last couple of problems on this side, 8, 9, and 10, and I will also be doing number 22 on the back side. That'll be in the second video.